Today we are discussing about the Amstrong number. So, first of all, we want to know what is Amstrong number. Amstrong number means if I give a 3-digit number as input, if I give a 3-digit number as input, suppose I am giving 153, right? Or first test case. If I given as input this, so 1 cube 1 power 3 plus 5 power 3 plus 3 power 3 3 power 3 which is equals to 153. If I perform 1 power individual digit power length, if I perform sum of digits to the power of length of the number, okay, sum of digits to the power of length, right? If I give 2-digit number 25, for example I am giving the 25 as the input, so it means 2 power 2 plus 5 power 2. If this expression value is equal to 25, then it is known as Amstrong number. See here, 153 is Amstrong number. Once we check, what is the 1 cube value? What is the 1 cube value? 1. So, what is the 5 cube value? 125. 125, right? So, what is the 3 cube value? 27, right? So, if we add these 1 plus 125, 126, 126 plus 27, what is the value? 153. After performing the power sum of digits with power length, right, we will get the same number as output. If the given output and the given input and the output is same, then it is said to be a Amstrong number. So here 153 is Amstrong number, 25 is not a Amstrong number, because see here 2 power 2 means 4, 5 power 2 means 25, right? So which is equal to 25 plus 4, 29. It is not equal to 25, right? So 25 is not a Amstrong number. See, so now let's write the pseudocode for the Amstrong number. I am reading the n value. After reading the n value, I am initializing the Amstrong number. Amstrong equal to 0. I don't know the Amstrong value, right? I am so initializing it with 0. So we know that if we want to extract the digit from the number, we will do modulo division by 10, right? So I am doing same process while n greater than 0, remainder equal to what? N modulo 10. To extract the last digit of a number, I am doing modulo division with 10. So after getting the modulo division, Amstrong equal to, I am adding the digit Amstrong plus power of what? Remainder, comma, what is the power? Length of the number, right? So first we want to calculate the length, right? After reading, I am storing it with temp, because of at last we are comparing with temp and Amstrong. After storing it with in, we want to calculate length, calculate the length. For calculating length, I will tell code. So after adding to the Armstrong, what can I do? Divide the number. Divide the number by 10. So simple. This is the code. After completion of performing operation, comparing with temp and Armstrong. If temp and Armstrong is equal to Armstrong, here also Armstrong. If temp equal to Armstrong, then I am printing yes, it is palindrome. Else I am printing not palindrome. No, just I am simply printing no. Okay. See here, I am tracing the loop. First of all, what is the length? I am taking the 153, right? N as 153. Temp is equal to also 153. What is the length? Length equal to 3. Okay. I am checking the condition. Is 153 greater than 0? Yes. Right. So I will enter into the loop. I will entering into the loop. Remainder equal to 153 modulo 153 modulo 10. What is the value of 153 modulo 10? 3, right? So after that I am adding the Armstrong to Armstrong. Performing operation I am adding to the Armstrong. Armstrong equal to Armstrong plus power of remainder comma length. Remainder to the power of length. So what is the Armstrong value initially? It's 0, right? 0 plus power of remainder. What is remainder? 3 comma 3, right? 3. So what is the 3 power 3? 27, right? So 0 plus 27 what? 27 only. So Armstrong becomes 23. 23, right? Sorry, 27. 3 power 3 is 27. So Armstrong becomes 27. After that, I will divide in the number by 10, right? So what is the number? 153 divided by 10. So n becomes 15. Again I am checking the condition. Is 15 greater than 0? Yes, condition is true. I am doing the modulo operation with 10. 15 modulo 10. What is 15 modulo 10? 5. So I am adding the previous Armstrong and power of 5 comma 3. 5 to the power 3. Right? 5 comma 3. So what is the 5 power 3 value? 5 power 3 is 125. So 125 plus 127. What is the value? 152. Right? 152. So again I am dividing the number with 10. So 15 by 10. What is the value? 1. Right? Is 1 greater than 0? Yes. Condition is true. So again I am doing modulo 10 operation. So 1 modulo 10 means 1, right? So again I am adding the previous Armstrong and 1 to the power of 3. 1 to the power of 3. So here what is the power of 1 to the power of 3 value? 1, right? What is previous Armstrong value? 152. 152 plus 1, which is equals to 153. So again I am dividing the 1 by 10. So what is the value? 0. Is 0 greater than 0? No, right? So when condition is false, it will terminates the loop, right? So then I am checking the condition. What is the temp value? 153. And what is the latest Armstrong value? 153. So both are equal, right? So this condition is true. Temp and Armstrong is equal. So it printing the S value, S, right? If I take 25 as 20, example 20, I am storing the same value in 10. I am tracing the another example, right? Okay. So what is remainder? 20 modulo 10. 20 modulo 10 means 0, right? So initially Armstrong value is 0. I am adding 0 to the power of 3. What is the 0 to the power of 3? 0 only, right? 0 plus 0? 0. So here 20 divided by 10 equal to what? 2, right? Again I am checking the condition. Is 20 greater than 0 here. So I am checking the condition. Is 2 greater than 0? Yes. I am doing the modulo 10 operations. 2 modulo 10. What is 2 modulo 10? 2. So I am adding the previous Armstrong value and 2 to the power of 3 value. What is the value of 2 to the power 3? 2 to the power 3 means 8, right? So previous Armstrong value is 0. 0 plus 8, 8. So again I am dividing the n value. N divided by 10. 2 divided by 10 means it becomes 0. Is 0 greater than 0? No. Condition is false. It will terminate from the loop. So the latest Armstrong value is 8. So what is the temp value? Here 20. Is 20 equal to 8? No, right? So the statement will not execute and it will print the no statement. It will print no. So let's code it in the online compiler. See here. I am reading the n scanf percentile d address of n, right? After reading the n value, I am storing it in the temp, right? Temp and again taking temp 1 to store n value only. This temp 1 is taking for counting the how many numbers are there in, how many digits are there in a what given input, right? Okay. After that I am counting the while temp 1 greater than 0 int remainder is equals to n modulo 10 and initializing the count value. Count is equals to 0. This this operation will returns the last digit, right? So in this way I am calculating the how many digits are present in the given number. So at last this loop will returns the how many digits are present in the given number or length of the given number. Okay. After that I will performing the same operations int Amstrong, right? Amstrong equal to initializing it with 0, right? While n greater than 0, remainder equal to n modulo 10. So after incrementing the count value, I will dividing with the 10, right? Sorry, temp 1 here. Here also temp 1. I am using temp 1. So remainder equal to n modulo 10, Amstrong equal to Amstrong plus power of remainder comma count. Count means length, right? After that I am dividing the n value with 10. After completion of the operation I am checking If temp equal to Armstrong, then print yes, printf yes, otherwise no, right? Else printf no. So see here, once I am tracing this loop, just I am storing the n value in temp1, right? So what is initially I am taking, suppose I am taking 25, right? In previous example we have seen that with 25, right? So now we want to calculate the length of this number. So I am taking as a example 25. What is the remainder now? Is 25 greater than 0? Yes, condition is true. So what is remainder? Remainder is 25 modulo 10, right? 25 modulo 10, which is equals to remainder equal to 5, right? 25 modulo 10 equal to 5. So initially count value is 0. So count value is incremented by 1. So count value becomes 1. After that I am dividing the temp1 value. Temp1 equal to, what is previous temp1? 25, right? 25 divided by 10. So temp1 becomes 2, right? So again I will iterating the loop. Is 2 greater than 0? Yes, condition is true. Remainder equal to 2 modulo 10. What is the remainder? 2. I will incrementing the again count value. Count becomes 2 and dividing with 10. Dividing the temp1 value with 10. It becomes 0. Is 0 greater than 0? Yes, condition. No, condition is false here, right? So when this condition is false, it will exit from the loop. After exiting the loop, what is the count value? 2, right? So here when I have taken 25 as input, so the length of this number also 2, right? It will returning the count value is length of the given number. The count value is length of the given number. So I am taking count value here to calculate the power of remainder and count. Okay. So see here, I am giving the input as 153. If I am giving as 153 as input, what is our output? So I am removing this, it is showing error. Here semicolon is missing. Okay. So 153 is, yes, Armstrong number. What is our second test case? Let's see. What is our second test case? 85, right? If I give an 85 as input, it will print no. 85 is not Armstrong number. If I give an third test case 9474, it will printing as yes. So 9474 also the Armstrong number. Okay. This is the program for finding Armstrong number or not. Okay. Thank you.